Hi, today's little quickie is the first in a two-part series of little quickies that's going to have to do with gauge blocks and sine bars, because I've received many questions about those two types of measuring tools, and many of the questions tend to indicate that the major problem with gauge blocks and sine bars isn't the tools themselves, but it's the math that goes with them. So this first of the two-part series is going to have to do with basic math for the shop. And that means resolving simple equations, ones that have just one variable, and basic trigonometry and basic triangle resolution. So let's take a look at basic equations. And right here I have what is a real basic numeric equation. 5 equals 5. Both sides of the equal sign equation, well, is the same. So 5 equals 5 is a numeric equation. Here I have happy face equals happy face, and that's a non-numeric equation, but it's still an equation. I could have said that going out with the boys too often equals you're going to be in trouble with your wife. That's another non-numeric equation. But these are basic equations, and they're resolved equations. They're ones that we don't have to figure out. But our problem is unresolved equations. And I have one right here. 2 equals 6 over unknown. And I'm just going to mention, quite often the unknown is called x or y. But I'm using just the unknown sign here because it'll be easier to see. So 2 equals 6 over unknown. That's a non-resolved equation because I don't know the answer. This side might be equal to this side. It could be an equation depending on what this unknown is. And the question here is to find what is this unknown. Well, to do that is relatively simple. One really basic rule that you have to remember is that anything you do to one side of an equation, you have to do to the other. You have to keep things balanced. And by adding things to both sides and reducing afterwards, well, we can get ourselves out of trouble and find the answer or resolve the equation. So let's take a look at that. 2 equals 6 over unknown. If I move over here, you can see that I've multiplied both sides of the equation by an unknown. So 2 times unknown equals 6 over unknown times unknown. It's the same equation. I've just added an unknown to each side. Now, to do that is fine, but we do it for a reason. And we do that because it permits us to simplify the equation. I've multiplied both sides by our unknown, and that means that 6 over unknown times unknown can be simplified. I can remove those two unknowns, and I still have the same equation because unknown over unknown equals 1. So 2 times unknown equals 6. And that's what I have right here. 2 times unknown equals 6. And again, to be able to isolate my unknown, I want the unknown to be alone on one side. Well, I'm going to multiply, or in this case divide both sides to get rid of the 2, or move it over to the other side. So 2 times unknown equals 6 is the same thing as 2 times unknown divided by 2, that equals 6 divided by 2. And again, what this gives us is the possibility to simplify the equation, and we end up with unknown equals 6 over 2. Well, that's almost resolved. I can simplify that fraction and say that 6 divided by 2 gives us an unknown that's equal to 3. Now, does that work with our original unresolved equation? Well, let's take a look. Is 2 equal to 6 divided by 3? 6 divided by 3 equals 2. So 2 is equal to 2. We've resolved the simple equation just by multiplying or dividing each side evenly and simplifying. And we did that to be able to isolate our variable, our unknown, and bring it alone on one side to find out what it represents in that equation. Now that's the basis for simple trigonometry. If you can do this type of operation, you can resolve most of your basic trig problems. Now, we looked at those equations so that we could resolve triangles. So we're going to have to look at the basics of triangles if we wish to resolve them. So let's take a look. Firstly, first thing you need to know, A, B, and C are the 3 internal angles of a triangle, any triangle, in any order. I've just put A, B, and C because that's what I felt like doing. But the A plus B plus C, the internal angles, always equal 180 degrees. And that's true for any triangle. So obviously, if you know 2 of the angles, well, the third one you can figure out by doing 180, which is the total of the 3, minus the 2 ones that you know. And that'll be your third angle. But this will be good to know to get you out of trouble sometimes and get you going to prepare a calculation for your trigonometry later on. So, sum of 3 internal angles on a triangle, always 180 degrees. Second thing we need to know is that any triangle that isn't a right angle triangle can be cut into 2 right angle triangles. And we do that simply by driving a line perpendicular to one of the 3 sides to the point opposite, or the angle through the angle opposite that starting point of 90 degrees. So any triangle can be made into 2 right angle triangles. And that's important because trig only applies to right angle triangles. So sometimes you're going to want to resolve a triangle by cutting it in 2 and resolving both ends of the triangle. And finally here, before we get going in our calculations, we have to get to know the terms that we're going to be using. And for that, I have a basic right angle triangle here. I don't know what angles I have, but I do know, since it's a right angle triangle, that one of the angles is exactly 90 degrees. Now, the triangle has 3 sides. It's important to know which is the hypotenuse. It's not always written on your drawing, or it never is actually. But the hypotenuse is the longest of the 3, and it's always going to be the surface that is opposite the 90 degree corner. The 2 other corners, the 2 other sides are just sides. And depending on which angle we're looking for, well, they'll be adjacent or opposing sides. So if I'm looking from this angle's vantage point, this surface or side of the triangle is the opposite side of this angle. And this side of the triangle is the adjacent side of this angle. And this is obviously always the hypotenuse. Now if I look from the vantage point of this angle, well, this becomes the opposite side, and obviously this becomes the adjacent side. So it's important to know this because in trig, opposite, adjacent, and hypotenuse are terms that come back often. So 90 degrees, 3 sides, the longest is the hypotenuse, and the 2 other sides can be opposite or adjacent depending on which angle I'm looking for. Another ace up your sleeve for resolving right angle triangles, well, is Pythagorean theorem. And Pythagorean theorem can help you find the length of one of the sides of a triangle if you know the 2 other sides. And it goes like this. C squared equals A squared plus B squared. And that's great, but you have to know that C squared is always the hypotenuse. So C, the hypotenuse square, equals both sides squared and added together. So the sum of the square of both sides. So c square equals a square plus b square. Now, if I decide arbitrarily that b is 2 inches and a is 1 inch, just to keep it simple, well, I can calculate it this way. C square equals 1 plus 4. Why 1? Well, 1 squared is 1 and 2 squared is 4. So 1 plus 4. C square equals 5. Now, c square equals 5 is great, but it doesn't tell me what c is. To find c, I have to make the square root of c. And remember, with our equations, if I do something on one side, I have to do it on the other. So I find the square root of c square, and the squares cancel out, and that ends up giving me c equals square root of 5. C being the hypotenuse. Well, square root of 5 is all fine and dandy, but I should resolve that finally to get a numerical distance. So if I do a square root of 5, it tells me that c is equal to 2.23661 inches. And that means that for a triangle, even if I don't know the angles except for this 90-degree angle, for a triangle that has one side at 1 inch and one side at 2 inches, that my hypotenuse will be 2.2361 inches. That can get you out of trouble sometimes when you're looking for one side. Now, we resolved for C, we could have resolved for A or for B. It doesn't matter which side as long as you keep it in that order. So if I'd known C, well, I would have put the number for C and not the number for A, and then isolated the A, and as we did in the first example. So Pythagorean theorem can get you out of trouble sometimes. Now, you have to be careful. At the start of the video, we saw how to isolate a variable when there was multiplications or divisions in the formula, or the equation I should say. And that's what we did at the very start. But the equation that we just looked at has an addition in it, and that's quite different. So if we want to isolate a variable here, we're going to have to change signs. And what that means is when you move something that is a plus or a minus from one side to the other, you have to change its sign. It's important to note that if a variable doesn't have a sign, it's considered to be a plus. So let's look at an example of isolating a variable when there's a plus or minus in the equation. 5 equals a plus 3. I have a plus. I want to isolate my variable, get it alone on one side. Which side really doesn't matter. So in this case, the easiest thing to do would be to bring the plus 3 over to this side. So if I change sides, since it's not a multiplication or a division, it's an addition, I change its sign. And that gives us 5 minus 3 equals A. And that would be, if I resolve it, 2 equals A. And if I bring this up to the original equation, I can say that yes, that's true. 5 equals 2 plus 3. So be careful with that. When it's not a multiplication or a division, and you isolate, you change something from one side to the other, all you do is change its sign. Trigonometry is the last weapon in our arsenal for basic triangle resolution in the machine shop. And it really isn't that complicated. Here's the basic principle. If I had a square, a 1-inch square, let's say, and it's the smaller of the two blue squares here, and I took that square and I grew it, I nurtured it, I fed it well, and grew it by 20%. We would all expect each of the 4 sides to grow by 20%. Because it's a square, and we know that all sides have to stay equal and even, and at 90 degrees one to the other. And triangles are no different. If I nurture this triangle, which is a square angle or rectangle triangle, by 20%, I expect each of the three sides to also grow by 20%. The problem with the triangle, though, is that the three sides aren't equal or even, as was the case with the square. So even if I'm growing in percentage at the same rate, I'm not growing in distance at the same amount. This is the shortest edge of this triangle. And if I stretch the triangle by 20% without changing any of the angles, well, this vertical edge is going to grow by 20%. But its distance that it's going to grow is going to be smaller than this one, because this shortest side of the triangle is always going to be shorter than the others in the same proportion. The same can be said for the hypotenuse. It's going to have to grow faster in distance than the other two sides will have to grow to keep everything in relation. And that's all trigonometry is. It's a constant that's already been calculated for us that lets us know that for a given angle of a rectangle or square angled triangle, the sides will grow by this much or at this rate. All we have to do then is put our dimensions in to find, if I grow this one by so much, how much will this one grow? That's all trig is. So let's take a look at the basic functions or basic equations that we use in trigonometry. The equations for simple trig in the machine shop are as follows. Sin of an angle equals opposite side of that angle over the hypotenuse of that triangle. Cos of an angle equals adjacent side to that angle divided by the hypotenuse of the triangle. And tan of the angle that I'm looking for is equal to the opposite side of that angle divided by the adjacent side of that angle. This we have to know. This is the basic. These are the equations that we're going to use to resolve our problems. Not all of them, but one of them for each problem we have to resolve. And choosing the right one will get us going. But for now, I want to state you have to learn that. Sin equals opposite over hypotenuse. Cos equals adjacent over hypotenuse. Tan equals opposite over adjacent. You have to know that. Now, these equations are important, but how can we show the relationship of the proportions that we get from these equations? The simplest way is to use a square that has no dimension to it, but that is a square. So we know that the four sides are all equal. And we know that the four corners are 90 degrees. Now, if I cut that square in two lengthwise or across, we're going to get 45-degree angles in each corner and form a right-angled triangle that has two 45 degrees. We know that because it's a square. And we also expect that this side in relation to that side will always be the same. Now, do we have an equation here that relates one side to the other? And the answer is yes. Tan of a given angle equals opposite the angle over adjacent of that angle. So let's take a look. Here's our angle, 45 degrees. If I apply this, I'll say tan of 45 is equal the opposite side over the adjacent. Now, if they're going to have to stay always the same, the relationship between them should be 1 to 1. And I would fully expect that tan of 45 degrees better be 1. So let's take a look. 45, tan. It's a factor of 1. That means that whatever I have here, I'm going to have here in relationship. And it's just that simple. So we see the relationships. Now with sine, the relationship is going to be the opposite side of the angle we're looking for divided by the hypotenuse. And with cosine, the relationship is going to be the adjacent side of that angle divided by the hypotenuse. And all we're going to get is a relationship, 1 to something else. How is it going to grow? So let's do an example. So here's our first example. We have a right angle triangle that has a base of 5 inches and an end angle here of 30 degrees. And what I want to discover is how long is the hypotenuse and how high is that triangle. So let's start with the hypotenuse. Makes no difference, but let's start with that one. Now, I have this adjacent side as known, and I'm looking for the hypotenuse. So what do I have here that has adjacent and hypotenuse in it? Cos. Cos of an angle equals adjacent over hypotenuse. That's going to be the one we want to use. So cos of 30 degrees, I type that into my little calculator, equals 5 divided by c. C being the hypotenuse. So cos of 30 gives us 0.8660 equals 5c. And now it's just like we did at the very beginning. All we want to do is isolate. I want to end up with my c all on its own. So to do that, I'm going to multiply both sides by c and then simplify the equation by getting rid of those two c's. And then I can divide both sides, as I'm doing here, by 0.8660 and simplify to end up with c equals 5 divided by 0.8660. If I calculate that, I end up with a hypotenuse of 5.7736 inches in length. That's all there is to it. Now, if I want to figure out my A, I'm going to be looking at probably using the same base and definitely using the same angle. So, what would give us that A? Well, if we look here, we have an opposite and an adjacent. Tan will give us opposite over adjacent, and I can use the numbers I have to calculate. So I'll get rid of this and we'll come back with the second example. So here we have our same triangle, 30 degrees, 5-inch base, but this time I'm looking for the height A. And since I have my adjacent side and I'm looking for the opposite side, I'm going to be using tan of the angle to figure things out. So tan of 30 degrees equals A, my unknown side, which is opposite, over 5, which is my adjacent side. Tan of 30 degrees gives me 0.5774, and that's still equal to A over 5. I want to isolate my A variable. So for that, I'm just going to multiply both sides by 5. So 0.5774 multiplied by 5 equals A over 5 multiplied by 5. I can simplify and reduce those two 5s, and that will give me that A is equal to 0.5774 multiplied by 5. If I calculate that, I end up with a height A equal to 2.8866 inches. And again, it's just that simple. Now, we have one last thing to resolve on this triangle that we don't know. It's the only one we don't know, and that's the angle up here. Now, we can do an inverse function to find it, or we can just use our sum of 3 angles in a triangle rule to figure it out. I know this corner is 90. I know this corner is 30. That gives me 120 degrees. Now, that leaves from 180 total, 60 degrees for this corner. So, 30, 60, 90, and I have my 3 lengths. Hypotenuse 5.7736, opposite side A 2.8866, the small height side, and the base of the triangle, well, is 5 inches. That's the basic functions, and that should be able to permit you to get out of most of the problems that you'll meet in the shop. But you're going to have to practice and get to know your calculator a little bit. So, Have fun, happy machining. See you next time for Joe blocks and sine bars.